Hi everybody, I'm Manuel Pagliuca, and this is the project for the course of Computational Geometry in Unimi at Milan. And the aim of this project is to study the triangulation techniques, the tessellation techniques, and some algorithm for the approximation of more complex objects like spheres, Taurus, and cylinder. From this algorithm will start from a simpler object like Prism, icosahedron, and a simple Taurus that will get more and more approximated. So let's start. The program, the GUI of the program is realized using HimGUI library, and the first bar, horizontal bar, just have a button that we can click and close the application. The main panels are these three panels. This is the center of the application, the most important things. And the more rich panel is this one on the right, called object panel. This panel will change in base of the objects object that I'm showing, and in base of which shader I'm using. So the first object that I'm showing there is the cube. This cube can be transformed using the correct matrices, so scaling matrix, positional matrix, scaling matrix, rotational matrix, and can't even be changed the way it is colored. So at the moment I'm using tessellation, so each primitive is interpolated using this RGB set, which means that this is red, this is green, and this is blue, and I can change this order by changing there on this combo box right here, this combo box right here, and I can even pick solid color, and I can change the whole color, which is kind of not really useful now for our objective. So let's see other objects like pyramid. This is always tessellation mode because I'm not changing the shaders. So same things. I forgot to say that there is 3 checkboxes that can enable the automatic rotation movement around the axis. So I have to move then this slider for making the speed go up and down, so I can play with it. And of course, for these simple objects like cube and pyramid, I can still I have the same object panel, but it will get more complex when I use something like the icosahedron, since this object is the base for approximation of a sphere. So for example, if I augment the subdivision level, I get a sphere, because since the algorithm is the concept of the algorithm is simple. I skip subdividing this triangle in other 4 triangles, and they are displayed in a way that they approximate a curved surface, so that can get to this. For a better resolution, I can put the simple shader, and I see this is a good sphere approximation. Even if I show the wireframe, this is all the triangles that are used right now. So I have a reference to the first 12 vertices of the icosahedron, so I can make them explode or implode by moving the value of their radius. So I can create these weird objects that are kind of cool. I can create this kind of bomb. Yeah, and I can play with it. I have a reference to the midpoints of each triangle, since each triangle will get subdivided by calculating the midpoints of the left, right, and down edge of the triangle. I have a reference to these midpoints radius for all the triangles. So if I change that, what happens is that they will implode or explode, and we get this explosion of the sphere, which is cool. And give some kind of weird effects that look kind of good. I can augment this subdivision, so I get a sort of pon-pon, the cheerleader thing that use for dancing at basketball, before basketball game. Anyway, I can move the wireframe and show the complexity of this, and I have that. Okay, so another object is the prism. I will go faster now, and I have this. So augmenting the level of sector, I can approximate a cylinder. If I move the wireframe, is easier to understand. If I put the wireframe, it's easier to understand. And the bases and the top bases, the base radius and the top radius, so this circle and this circle in the back, are interpolated between them. So if I make smaller one, I can get a cylinder, a cone, sorry, I can get a cone. If I augment the height, I can get this effect, and it's kind of straightforward. It's just a cylinder and that became a cone. So I can decrease even the other base and I get a line. Okay, can move, it's just a line. Okay, not really a line, it's just a really small cylinder actually. So the last object is the Taurus. It's cool, and it starts from implementing the equation of the Taurus, where we have two circumference and two circles to approximate. So the first one is the big circle right here, and the other is the tubular circle right here that goes around this. So if I augment the segmentation for the big circle, I get a really nice circle actually that look good, but it will have these edges on the surface, because the triangle that I'm using here are not enough for making it look smooth. So the tubular circle is not well approximated, but we can always augment them. So you see this triangle are getting more and more, and I'm getting a cool surface, a torus, which is a donut. Donuts are great, and even here, look around, this is okay, this is a good looking torus. I can even modify the big radius, the main radius of the torus, making a big ring or a small ring. The same, I can augment the tube radius, so it will get a bigger and fatter tube radius. If I show the wireframe, they even can collide if I augment enough and have this kind of sphere inside the sphere. So this will change the shaders. So in this case I'm using the simple shader, and everything is interpolated. The other is triangle shader. I can show the tessellation of the triangle. Let's do for that. Okay, but reset this. Reset that. Okay. So the triangulation can show me the barycentric coordinates of the triangles. I can play with inner level and the concentric triangle. I can play with the external edges triangle, and I can lock all levels and move them together. And this is applicable to every object, because for every object there is a triangulated version of that. This is the basis actually. And for the cube there is another domain, the quad tessellation, which show me these quad surfaces that are approximated in the OpenGL way. So inner level for the vertical region, or horizontal in this case. The vertical region is the second inner level. The other outer level are for the edges. So this is it. And there is a local levels for this. And this quad domain of OpenGL is implemented only for cube. So if I use this for another, I can see anything. I can't see anything, and there is an error saying quadrilateral primitive not available for this object. So this is everything for my project. It was really good and cool to understand these topics of OpenGL. I really liked it, and I use as reference a lot of internet sources. For the algorithms part, I used the Songho website. I think was written like that, but I don't remember actually if it's the correct name of the website. For the tessellation, for the tessellation study part, I use the OpenGL Super Bible book and the Red book. Actually, I combined both together because I think both together give a good image about what tessellation was and is, and nothing more. As library, I use GLFW and Glue as wrangling library. So this is it, and this is the year 2021, and there is Manuel Pagliuca. Have a nice day, and thank you for watching.